Here's the third proof, our first arrow in proof, and a complex proof compared to what we've seen so far. The proof uses the rule of arrow in, and that rule permits us to assume a statement is true in order to see what follows from that, and depending on whether we like what follows from that, conclude by arrow in that a conditional is true whose antecedent is a provisional assumption and whose consequent is a derivative of that. I've put this proof in a format I encourage you to use when you're working at home. Unfortunately, there's no way that I can find in Sandy to effectively use this box in Sandy itself, other than posting videos of paper and pencil work. At any rate, I'm going to cover this proof in two videos. First, look at the derivation from this provisional assumption of this statement, and then complete the assumption dependence column that has to be part of any proof that makes a provisional assumption. So let's start with the derivation of O and P from the assumption that L and M is true. If we can get to there without violating the big rule, the subject of the second video, if we can get to there, then we can construct a conditional that is the conclusion of the argument. So let's look and see what we've got. Three premises. A assumption of a conjunction. You have to assume L and M together, not L and then assume M separately. Assume L and M, and that gives you the antecedent of line 1 and of line 3 once you separate them out from line 4. So let's get L from 4 by and out, and use that L to get R and R arrow S out of line 1 by arrow out from 1 and 5. Then let's separate M out from line 4. To get the antecedent of line 3, so we can get out of line 3 by arrow out its consequent, R and O. From 3, 7, arrow out. From R and O, we can get O by 8 and out, and O is one of the things we need to get the conjunction O and P. To get P, let's get the antecedent of line 6, R, from 8 by and out, and with that R, let's get S from 6, 10, arrow out, and with that S, let's get P from line 2 by 2, 11, arrow out. We now have the two conjuncts of what turns out to be line 13. We get O and P from lines 9 and 12 by and in, and that gives us the consequent of the conditional as a derivative of the assumption of its antecedent. So we can say at line 14 that L and M arrow O and P by 4 through 13 by arrow in. So at this proof, the proof has been, at this point, the proof has been jarred, but basically we've derived the conclusion. All it remains to do is to see if we can complete this assumption dependence column successfully, and that's next.